Today, we are going to discuss trigonometric substitution. So integrals the form of the integral of the square root of a squared plus or minus u squared of dx, or the integral of the square root of u squared plus or minus of a squared of dx. So we can evaluate this kind of integrals by using trigonometric substitution. So we begin by drawing a right triangle and leveling the sides of a, u, and the square root of a squared plus or minus u squared, or the square root of u squared plus or minus a squared. Then we integrate the resulting trigonometric expressions. So here are some guides on how are we going to solve using trigonometric substitution. So we assume here that a is greater than 0. So number one, for integrals involving the square root of a squared minus u squared, we let u equals a sine theta. Then the square root of a squared minus u squared is equal to a cosine theta, where the value of theta is greater than or equal to negative pi over 2 and less than or equal to pi over 2. So here is the illustration for that, for number one. So we have here, if this is now our angle, and then using the formula of u equals a sine theta, so let us solve for sine theta, and that will come up in this form. Okay, so for number two, we have for integrals involving the square root of a squared plus u squared, we let u equals a tangent theta. We have to follow also the foundation. Then the square root of a squared plus u squared is equal to a secant theta, where the value of angle theta is greater than negative pi over 2 and less than pi over 2. For number 3, for integrals involving the square root of u squared minus a squared, so we let u equals a secant theta. Then the square root of u squared minus a squared is equal to a tangent theta if u is greater than a, where 0 is less than or equal to theta and theta is less than pi over 2. Then we're going to use the value of negative a tangent theta if u is less than negative a, where pi over 2 is less than theta and less than or equal to pi. Okay, to illustrate this one, let us solve some exercises using these three formulas. For number one, I have here the integral of the square root of 1 minus x squared. So in this formula, this is now similar to formula number 1, wherein the square root of a squared minus u squared. So in that case, we are going to use u equals a sine theta. So I will write here, u is equal to a sine. I will use now the angle of alpha instead of theta. Okay, u is equal to a sine alpha. Then this is the right triangle. So therefore, this is now my alpha. So from the given, I have u squared is equal to x squared, and a squared is just equal to 1. So u now equals x, and a is just equal to 1. Then by substitution now, I have u is equal to a sine of alpha. Then u is equal to a is 1, so sine alpha. But u here is x, so I will write now x is equal to sine alpha. And then take the derivative of this. So we have now dx is equal to cosine alpha d alpha. So from here, from the data, I'm now going to define sine alpha. So sine alpha is coming from the definition of opposite side over the hypotenuse. So opposite side, we have x is the opposite side, and the hypotenuse is 1. And therefore, to solve for the third side, we're going to use the Pythagorean theorem. So according to the Pythagorean formula, so this will give us now the square root of 1 minus x squared. So after that, we are now going to change the variable x and dx from the given. So we can now have the integral of the square root of 1 minus the meaning of x here. We have sine alpha, and then we have the square, then times dx stands for cosine alpha d alpha. So simplifying the integrand, so we can have now the integral of 1 minus sine squared alpha, the square root of this, times cosine alpha d alpha. But the meaning of 1 minus sine squared alpha based on the Pythagorean identity, so that is now the equivalent of the square root of cosine squared alpha times cosine alpha d alpha. But taking the roots, so we can now write here the integral of the square root of the square of cosine alpha is just equal to cosine alpha times another cosine alpha of d alpha. So multiplying that one, so we can now write here cosine squared alpha d alpha. So from here, we are going to use the half angle identity. So we can now write here 1/2 times 1 plus cosine of 2 alpha and d alpha. We are going to expand the meaning of the integrand. We can now have 1/2 of d alpha plus the integral of 1/2 of cosine 2 alpha d alpha. Now, we are going to take the integration of the first term. So the continuation is here. So from here to there. So the integration of 1/2 d alpha is just equal to 1/2 of alpha plus 1/2 times the integral of cosine 2 alpha. We have here 1/2 is the coefficient of the angle. So take the reciprocal of the angle. So it becomes now 1/2. And then the integral of cosine, we have now sine of 2 alpha plus a constant. But we have what's the meaning of our alpha? We are going to change now our given in terms of x. So from here, so we have 1/2 times alpha. So the meaning of alpha here, we have alpha here is equal to arc sine of x. So I can replace now alpha as 1/2 times arc sine of x plus 1/2 times 1/2 is 1/4, and then sine of 2 alpha plus a constant. Now we are going to use the identity of sine 2 alpha. So I can have now 1/2 of arc sine of x plus 1/4 times the identity of sine 2 alpha, that is 2 sine alpha cosine alpha plus a constant. So the first term now is 1/2 of arc sine of x plus 1/4 times 2 is 1/2. And the meaning of sine alpha is this one. We have x is equal to sine alpha. So instead of writing sine alpha, I will now write x times the meaning of cosine alpha. So please refer it here in the right triangle. So cosine alpha means adjacent over hypotenuse. So the adjacent side is the square root of 1 minus x squared, and the hypotenuse is 1, so no need to write 1, and then plus a constant. So therefore, the final answer now is 1/2 of arc sine of x plus 1/2 of x times the square root of 1 minus x squared plus a constant. In number 2, we have the integral of the square root of 4x squared minus 1 over x dx. So in the given, it started with 4x squared, that is now equivalent to u squared minus a squared. So that formula of u squared minus a squared. So we are using this equation. So we are going to let u equals a second alpha. So we have to use u equals a second alpha. So I will write here u is equal to a second of alpha. So if this is now my alpha here, so u squared equals 4x squared. Then a squared equals 1. Therefore, u equals the square root of this. We have 2x. And a is the square root of 1 is just the same with 1. Then I'm going to define now u is equal to 2x and a equals 1. So u here is equal to a second of alpha. But u equals 2x, so I write 2x is equal to 1 times second alpha. Or that is now just second of alpha. Then after that, let us solve for x. So solving for x, so we have now 1/2 of the second alpha. Always solve for x after this equation. Then after that, so we are going to take the derivative. So the derivative of x is just equal to 1 dx or just dx. And the derivative of second alpha, we have now 1/2 of second alpha times tangent alpha d alpha. So since we have now dx, the meaning of dx is this one, and we also have the meaning of x, so we can now rewrite the given in terms of alpha. So we can now write here the integral of the square root of 4 times x squared. So the meaning of x is 1/2 times second alpha, and then this will be squared from the given 4x squared, and then minus 1, and then all over the meaning of x, which is 1/2 of second alpha times the meaning of dx, which is 1/2 times second alpha tangent alpha d alpha. So by simplifying the integrand, so we can write here the square root of 4 times the square of 1/2 of second alpha can be written as 1/4 of second squared alpha minus 1 all over 1/2 of second alpha times, I will just copy that one, the meaning of dx. So 1/2 of second alpha tangent alpha d alpha. So simplifying further, the radicand, so we have 4 times 1/4 is 1. So the remaining term now is the integral of the square root of second squared alpha minus 1 over 1/2 of second alpha times 1/2 of second alpha tangent alpha d alpha. But the meaning of second squared alpha minus 1, using the identity of the radicand, so we can write the square root of tangent squared alpha over 1/2 of second alpha times 1/2 of second alpha tangent alpha d alpha. But the square root of tangent squared alpha is just equal to tangent, so we can write now tangent alpha over 1/2 of second alpha times 1/2 of second alpha tangent alpha d alpha. Now let's try to simplify further. So 1/2 divided by 1/2 is 1. Second alpha divided by second alpha is also 1. So therefore this can be cancelled, cancel, cancel, cancel. And the remaining terms now we have tangent alpha times tangent alpha d alpha. So I will just write it here from there. So we have the integral now of tangent squared alpha d alpha. So tangent squared alpha has no direct integration. So I will use adding and subtracting. We have now the integral of tangent alpha plus 1 minus 1 of d alpha. So separating this one, so I can rewrite this given as tangent squared alpha plus 1 of d alpha minus the integral of d alpha. Now, so the integration of tangent squared 1 alpha plus 1 is just equal to tangent alpha minus alpha plus a constant. Now I'm just going to change the meaning of alpha. So let's go back first. The meaning of alpha can be, so I can write here. So we have alpha is equivalent to arc secant of 2x. So I'll define first secant alpha. So secant alpha means hypotenuse over adjacent. So hypotenuse is 2x, and then the adjacent is over 1. So to solve for the third side, we're using now the Pythagorean formula, and it will give us now the value of 4x squared minus 1. So from here, we can now define our tangent alpha. So tangent alpha means opposite over adjacent. So that is now the square root of 4x squared minus 1 over 1, or that is just the square root of 4x squared minus 1. So we have here tangent alpha is the square root of 4x squared minus 1 over 1. So no need to write over 1 because a number divided by 1 is still that number. So minus the meaning of alpha, we have alpha now is arc secant of 2x. So I will write here now arc secant of 2x plus a constant. So finally, so the answer now for our given, which is integral of the square root of 4x squared minus 1 over x dx, is equivalent to the square root of 4x squared minus 1 minus arc secant of 2x plus a constant. Okay, for number 3, we have the integral of 1 over x squared times the square root of 9 plus 4x squared dx. Because of the radicand of 9 plus 4x squared, that is similar to the square root of a squared plus u squared, therefore we are going to use the formula number 2, which means we are going to let u equals a tangent alpha. So by writing u here, u equals a tangent alpha. U squared equals 4x squared and a squared equals 9. So it follows that u equals 2x and a equals 3. So using this formula, we can now write u equals 2x, which means 2x is equal to a tangent alpha, where a is 3, and then tangent alpha. Solving for x, I have now x equals 3 over 2 of tangent alpha. Then we take the derivative for this. So we have derivative of x is 1. So 1 dx is just equal to 3 over 2 of secant squared alpha d alpha. Or I can use dx equals 3 over 2 of cosine squared alpha d alpha. So the reason why I'm using now the reciprocal of secant alpha, it's because I just want to deal with sine and cosine, and besides, the radicand is in the denominator. So now we are going to rewrite the given. So we have 1 times dx is just equal to dx. So I will write now dx as 3 over 2 cosine squared alpha d alpha all over. So we have the denominator now is x squared, wherein the meaning of x is 3 over 2 tangent alpha. So we have 3 over 2 of tangent alpha, and then will be enclosed to the parentheses, then in power of 2 times the square root of, let's extend this one. So we have the square root of 9 plus 4 times the meaning of x again. We have 3 over 2 of tangent alpha, and then power of 2. And then the meaning now of dx is already there. Okay, so simplifying this, so I can rewrite that one as 3 d alpha So this, since this is a denominator, so I will just write it down now. So I can write 2 cosine squared alpha times the square of 3 halves of tangent alpha can be written now as 9 over 4 of tangent squared alpha times, simplifying the radicand, we have now 9 plus, so the square of 3 over 2 is 9 over 4 times 4. So we have now 9 plus 9 of tangent squared alpha. By simplifying further, so we can now write as the integral of 3d alpha over 2 cosine squared of alpha times 9 over 4. And I will use the ratio identity of tangent squared alpha. So we have now sine squared alpha over cosine squared alpha times, there's a common factor of 9. So we have now the square root of 9 is 3. So we can write now as 3 times the square root of 1 plus tangent squared alpha. And then by simplifying further, so I can write now 3d alpha. So we can cancel cosine squared and cosine squared. So 2 times 9 over 4, that will give us now 9 over 2 of sine squared alpha times the identity of 1 plus tangent squared alpha is secant squared alpha, but there is a square root of that. So take the square root of secant squared alpha. So therefore it gives us now 3 secant alpha. So from here, let's go there. So from here, we can now simplify further. So I have a numerator of 3. I also have a denominator of 3. So therefore 3 divided by 3 equals 1. So I can just write now here as d alpha over 9 over 2 of sine squared alpha times secant alpha can be written as 1 over cosine alpha. So simplifying further, so we still have a numerical value of 9 over 2. Since 9 over 2 is in the denominator, so I will divide it from 1 divided by 9 over 2. So it gives us now a numerical coefficient of 2 over 9 times the integral of d alpha over sine squared alpha over cosine alpha. So simplifying further, we have d alpha divided by sine squared alpha over cosine alpha. So we can write now the quotient as cosine alpha d alpha over sine squared alpha. So in this case, I'm going to write u as sine alpha, and then the derivative of that will give us cosine alpha d alpha. So by rewriting the given now in terms of u and du, I can write now 2 over 9 times the integral of cosine alpha d alpha, which means du, over u is sine alpha. So we have sine squared, it becomes now sine squared. So by integrating that one, it will give us now 2 over 9 times u to the power of negative 1 over negative 1 plus a constant. So finally, our answer will give us the negative of 2 over 9 of sine alpha plus a constant. But we still have the meaning of alpha. So from the answer of negative 2 over 9 of sine alpha plus a constant, so we are going to find the value of sine alpha from this triangle. So it says that sine alpha will be equal to opposite over hypotenuse, which is now 2x over the square root of 9 plus 4x squared. So I will write it here that sine alpha is equal to 2x over the square root of 9 plus 4x squared. Now, this is equivalent to replacing down the meaning of sine alpha. So I can write now negative 2 over 9 times 2x over the square root of 9 plus 4x squared and then plus a constant. So by simplifying further, so I can write first as negative 2 over 18x over the square root of 9 plus 4x squared plus a constant. So dividing this again, so we can write now as the negative 2 times the square root of 9 plus 4x squared over 18x plus a constant. But negative 2 over 18 can be reduced as the negative square root of 9 plus 4x squared all over 9x plus a constant. Okay, for number 4, we have the integral of the square root of 25x squared minus 4 all over x dx. So the radicand is similar to the square root of u squared minus 4. So therefore, we are going to use the equation of, we have u is equal to a secant alpha. Okay, so our u squared there is 25x squared. So a squared equals 4. So u now equals 5x and a equals 2. So using this equation, we have u equals a secant alpha, but the meaning of u is 5x. So I write 5x equals a secant alpha, where a is 2, and then secant alpha. Solve for x, so therefore I divide both sides by 5. So I write x is equal to 2 over 5 of secant alpha. And then take the derivative of this. So that's now dx is equal to 2/5 of secant alpha tangent alpha d alpha. So I will define first my secant alpha. So from here, I can write now secant alpha is equal to 5x over 2. So after defining the secant alpha, I will write now in the right triangle. So secant alpha means hypotenuse over adjacent. So hypotenuse is 5x and the adjacent side is 2. To solve for the third side, let us use again the Pythagorean formula, and this will give us the value of the square root of 25x squared minus 4. So after that, this is our alpha here, and we are going now to rewrite the given. So we have the square root of 25 and take the meaning of x. So our x is 2 over 5. So we have 2 over 5 of secant alpha, and then raise the power of 2, and then minus 4 all over, the meaning of x again is 2 over 5 of secant alpha times the meaning of dx, we have 2 over 5 of secant alpha tangent alpha d alpha. So by simplifying the radicand, we have the square of 2/5. It becomes now 4 over 25. So 4 over 25 of secant squared alpha. So 4 over 25 times 25. So the remaining there is the integral of the square root of 4 secant squared alpha minus 4 all over. So 2/5 divided by 2/5, that will be cancelled. So I have one secant alpha and secant alpha. I can cancel this one also. So the remaining term now is times tangent alpha d alpha. So by simplifying the radicand, we have now the integral of, there's a common factor of 4. So we can write now the square root of 4 times secant squared alpha minus 1 times tangent alpha d alpha. The square root of 4 times secant squared alpha minus 1. Secant squared alpha minus 1 means tangent squared alpha. Okay, we can write now the integral of the square root of 4 tangent squared alpha times tangent alpha d alpha. So we have now the square root of 4 tangent squared alpha will give us now the integral of 2 tangent alpha times tangent alpha d alpha. So multiplying that one, we have now 2 tangent squared alpha d alpha. So taking now the identity of this, so we can write 2 times, we have tangent squared alpha plus 1 minus 1 of d alpha. So from there, we can write now 2 times, we have the tangent squared alpha plus 1 of d alpha minus 2 times d alpha. So we can write as 2 times the integration of tangent squared alpha plus 1 is equivalent to tangent alpha minus 2 alpha plus a constant. And the meaning of tangent alpha can be defined in the right triangle. So tangent alpha means opposite over adjacent. So we can write as the square root of 25x squared minus 4 over 2. So I will write it here. We have 2 times the square root of 25x squared minus 4 all over 2 minus 2 times the meaning of alpha. We're going to find it here. So alpha can be defined here as, I'll write it here, alpha na can be defined as the arc secant of 5x over 2. We have arc secant of 5x over 2 and then plus a constant. So simplifying further, so 2 here and 2 will be cancelled. So I can write now the square root of 25x squared minus 4 minus 2 arc secant of 5x over 2 plus a constant. Or in some other cases, instead of writing 2 arc secant of 5x over 2, we will take the reciprocal of 5x over 2. At the same time, we're going to take also the reciprocal of secant. So therefore, we have now the final answer of the square root of 25x squared minus 4 minus 2 arc cosine of 2 over 5x plus a constant. For number 5, we have the integral of 1 over x raised to 4 times the square root of 9 minus x squared. So because of the radicand, we have a squared minus u squared. So we are going to let u equals a sine alpha. So in our given, u squared equals x squared and a squared equals 9. So u here equals x and a now equals 3. To use now the equation, replace u by x. So therefore x is equal to a sine alpha, where a now is 3 and then sine alpha. That is now the value of x. So we can now find the derivative of x. We have dx is equal to 3 cosine alpha d alpha. So from here, we can also define our sine alpha. So a sine alpha now becomes x over 3. So if I'm going to write the given in our right triangle, so if this is our alpha, so sine alpha means opposite over hypotenuse. So the opposite side is x and the hypotenuse now is 3. So solving now for the third side using the Pythagorean formula, we can write now as 9 minus x squared. So after that, we're going to rewrite the given and replace the meaning of x and dx. So we can now write 1 times dx just dx, so therefore dx now becomes 3 cosine alpha of d alpha over x means 3 sine alpha. So we have 3 sine alpha and then raise to the power of 4 times the square root of 9 minus, the meaning of x again is 3 sine alpha and then square. So simplifying this, so we can write now as 3 cosine alpha d alpha all over 3 to the fourth power means 81. And then we have sine to the fourth power of alpha times the square root of, we have 9 minus the square of 3 sine alpha can be written as 9 sine squared alpha. So simplifying further, so we can write now the numerator of 3 cosine alpha d alpha all over, we have 81 of sine to the fourth power alpha times, so we have a common factor of 9, so we can write now as 9 times 1 minus sine squared alpha. So the 1 minus sine squared alpha is equivalent to cosine squared alpha. So we can write now as 3 cosine alpha of d alpha all over 81 of sine to the power of 4 alpha times, we have the square root of 9 is 3, and the meaning of 1 minus sine squared is cosine squared. So take the square root of that, it will give us now 3 cosine alpha. So as you can see here, we have 3 cosine alpha d alpha in the numerator, and I also have 3 cosine alpha in the denominator. So we can now cancel that one because it will just give us the value of 1. So therefore, we have here now d alpha. The remaining terms now are d alpha over 81 of sine to the fourth power of alpha. So I can write that one now as 1 over 81, the integral of, since sine to the fourth power of alpha is in the denominator, so to avoid having a fraction form, so I will take the reciprocal identity. So the reciprocal identity now of sine will be equal to cosecant. So we can write now cosecant to the fourth power of alpha d alpha. So from here, we can now write as 1 over 81 times, we'll factor that 1. So we have cosecant squared alpha times cosecant squared alpha d alpha. So one of the cosecant squared alpha, we are going to use the Pythagorean identity. So we can write now 1 over 81, the integral of cotangent squared alpha plus 1 times cosecant squared alpha d alpha. Now from here, I will let now u equals cotangent alpha, and du here is equal to negative cosecant squared alpha d alpha. So I have negative cosecant squared alpha d alpha, but I only have here cosecant squared alpha d alpha. In other words, I have a coefficient factor of negative 1. So therefore, we can write negative 1 times 1 over 81. I have the negative of 1 over 81 times the integral of, the meaning now of cotangent is u, so we can write now u squared plus 1 times the meaning of cosecant squared alpha d alpha, which means du. By integrating this one now, we can write the negative of 1 over 81 times u cubed over 3 plus u plus a constant. But we have to rewrite again the meaning of u, which is cotangent alpha. So we can now write here as the negative of 1 over 81 of cotangent cube alpha over 3 plus cotangent alpha plus a constant. So we are going now to rewrite the meaning of alpha in terms of x. So I will just rewrite the last term there was the negative of 1 over 81 times cotangent cube alpha over 3 plus cotangent alpha plus a constant. So first of all, I'm going to use distributive property. So it will give us now the product of negative 1 over 243 of cotangent cube alpha. So negative 1 over 81 times cotangent alpha will give us negative 1 over 81 of cotangent alpha plus a constant. Now let us take the meaning of cotangent alpha from the triangle. So cotangent alpha means adjacent over opposite side. So the adjacent side is the square root of 9 minus x squared. Opposite side is x. So therefore, we can write now as the negative of 1 over 243 times the square root of 9 minus x squared over x, and this will be raised to the power of 3 minus 1 over 81 times the square root of 9 minus x squared over x, and then plus a constant. So in the first term can be written as negative 1 over 243 times 9 minus x squared to the power of 3 halves over x cubed using distributive property minus 1 over 81x times the square root of 9 minus x squared plus a constant. Or we can multiply that one again. So that's now the negative of 9 minus x squared to the power of 3 halves all over 243 of x cubed minus square root of 9 minus x squared all over 81x plus constant. For number 6, we have integral of x to the 5th power over the quantity of 36x squared plus 1 raised to the power of 3 halves dx. So because of 36x squared plus 1 as the radicand, then we can use now the formula of letting u equals a tangent alpha. So our u squared is 36x squared. So a squared equals 1 and u equals 6x, a equals 1. So writing this equation, we can write now 6x equals a is 1. So no need to write the coefficient of 1 and then tangent alpha. Solving for x, we can write x is equal to tangent alpha over 6. So from the definition of tangent alpha equals 6x, so we can write it here. This is now alpha. So tangent alpha is equal to opposite over adjacent. So opposite side now is 6x, and it has a denominator of invisible 1. So we have now 1. So therefore, the hypotenuse will be solved by using the Pythagorean formula, and it will give us the answer of 36x squared plus 1. Now, after that, we have to take the derivative. So the derivative of x dx is equal to 1/6 of secant squared alpha d alpha. Now, we can rewrite the given, replacing the value of x and dx in terms of alpha. The integral of x means tangent alpha over 6. So I can write now tangent alpha over 6 power of 5 all over 36 times the meaning of x is tangent alpha over 6 and then raise to the power of 2 plus 1 and then open and close bracket of 3 over 2 times the meaning of dx. Now we have 1 over 6 of secant squared alpha d alpha. So by simplifying, we can write tangent to the 5th power of alpha over 6 to the power of 5 times 1 over 6 of secant squared alpha d alpha all over, we have 36 times tangent squared alpha over 36, that is coming from the square of tangent alpha over 6. So plus 1, open and close bracket to this, we have the power of 3 halves. So simplifying the numerator, so we have tangent to the power of 5 alpha over 6 to the fifth power times 1 over 6 of second squared alpha d alpha. So simplifying the numerical coefficient of 1, 6 and 1 over 6 to the power of 5, it gives us the product of 1 over 6 to the 6th power of the integral of tangent to the fifth power of alpha times secant squared alpha d alpha, while the denominator, which is now the product of tangent squared alpha plus 1, and this is raised to the power of 3 halves. So simplifying further now, we have 1 over 6 to the 6th power is 7,776. So times the integral of tangent to the fifth power of alpha times secant squared alpha d alpha. So first, we are going to take the identity of tangent squared alpha plus 1, which is secant squared alpha to the power of 3 halves. So next we have to simplify the denominator. So I will write first the other terms. We have now 1 over 7,776 times the integral of tangent to the fifth power alpha times secant squared alpha d alpha. So simplifying the denominator, we can now have secant cube alpha. So next we have to divide. So the remaining terms for that, now we have 1 over 7,776 times the integral of tangent to the fifth power of alpha over secant alpha d alpha. So using the rules in the powers of secant and tangent, so we are using the rule number 5. So we are going to rewrite the given in terms of sine and cosine. So we can write as 1 over 7,776 times the integral of sine to the fifth power of alpha over cosine to the fifth power of alpha all over 1 over cosine alpha d alpha. So dividing this one, sine to the fifth power alpha over cosine to the fifth power of alpha divided by 1 over cosine alpha, it will give us the quotient of, I will write first the coefficient, 1 over 7,776 times the integral of sine to the fifth power of alpha over cosine to the fourth power of alpha d alpha. So from the last term that I have in the other slide, so I write now 1 over 7,776 times the integral of sine to the fifth power of alpha over cosine to the fourth power of alpha d alpha. So we are going to factor out sine to the fifth power of alpha and save sine alpha. So we can write now 1 over 7,776 times sine to the fourth power of alpha times sine alpha d alpha over cosine to the fourth power of alpha. So we are going to factor further the sine to the fourth power of alpha, and that can be written as we have 1 over 7,776 times sine squared alpha to the power of squared all over cosine to the fourth power alpha times sine alpha d alpha. And from the identity of sine squared alpha, so we can write now 1 over 7,776 times 1 minus cosine squared alpha to the power of 2 all over cosine to the fourth power of alpha times sine alpha d alpha. Now I'm going to let u as cosine alpha And the derivative of cosine alpha is the negative sine alpha d alpha. So I have here a sine alpha d alpha comparing to this. So I have coefficient factor of negative 1. So from there, I can write now as negative 1 over 7,776 times the integral of 1 minus u squared to the power of 2 all over cosine to the fourth power can be written as u to the fourth power times sine alpha d alpha means du. So simplifying that further, we have negative 1 over 7,776. We have 1 minus 2u squared plus u to the fourth power all over u to the fourth power du, and then divide it first. We have the negative of 1 over 8 times the integral of dividing this one, we have u to the power of negative 4 minus 2u to the power of negative 2 plus 1 of du. Then after that, we're going to integrate. So I have the negative of 1 over 7,776 times, so what is it here? We have u to the power of negative 4, so the integration of that becomes u to the power of negative 3 over negative 3. In the next term, we have negative 2u to the power of negative 1 over negative 1, negative 2u to the power of negative 1 over negative 1. In the next term, we have the integral of 1 du is just equal to u. So plus u, then plus a constant. So simplifying this further, we can write now as the negative of 1 over 7,776 times the meaning of this, we have negative of 1 over 3 u to the third power, negative 2 and negative 1, we have positive 2 over u, the first power, plus u plus a constant. We have now, so I will not multiply that once, I will just write here a common factor of negative 1 over 7,776 times the negative of 1 over 3, and the meaning of our u is cosine alpha. We have cosine cubed of alpha plus 2 over cosine alpha plus cosine alpha plus a constant. Now we are going to find the meaning of cosine alpha from the right triangle. So cosine means adjacent side over hypotenuse. So we have 1 over the square root of 36x squared plus 1. So I will write here equals the negative 1 over 7,776 times the negative of 1 over 3 times 1 over the square root of 36x squared plus 1. And then this is raised to the power of 3 plus 2 over the square root of 36x squared plus 1 plus the square root of 36x squared plus 1 plus a constant. So simplifying this further, we have negative 1 over 7,776 times the negative of square root of 36x squared plus 1, and this is raised to the power of 3 over 3 plus 2 over the square root of 36x squared plus 1 plus the square root of 36x squared plus 1 plus a constant. So simplifying this one, we have now, so we have negative times negative, so we can write now positive. Square root of, we have 36 x squared plus 1 to the power of 3 halves. And then 7,776 times 3, we have 23,328 minus negative times positive 2, we have negative. So we have negative 1 over 3,888 times the square root of 36x squared plus 1. And then negative times positive. So we have now the negative of square root of 36x squared plus 1 all over 7,776 plus a constant.